because if you, proton-based donation and acceptance is Bronsted-Lowry. Electrons is where Lewis comes in. Because when you do Lewis structures, you're concerned with the octet rule and the electrons in the structure. That's the difference between Bronsted and Lewis.
Okay.
Lewis encompasses all things. Like Lewis will be valid for every single acid and base that can ever be conceived of. Whereas Bronsted-Lowry specifically deals with an exchange of a proton. But if there's no exchange of a proton, what do?
You can't do anything.
Yeah.
Okay. So then it'd be kind of like these things right here.
Yeah. And typically that's what you'll see is a Lewis base will have a negative charge on it. Or, wait a minute.
What?
Check that again.
It's positive.
I know. What about this stuff?
Wait.
I meant to do that. That was like,
Deny me, Mike.
okay.
Okay.
What is NH3 based on Bronsted-Lowry?
It's a base.
Right. That holds true in Lewis. Lewis just has a different perspective on how bases work. Bronsted just looks at the proton exchange, whereas Lewis looks at the electron exchange. And
So then how does, what's going on in this then?
I'll show you real quick. They really need better pens.
Yeah, I probably do.
Okay. All right. So in the Lewis base, I'll just use the one you have there.
Oh, the black.
Yep. Once you go black, you never go back.
Exactly. Good right there.
Okay. So we know that from Bronsted-Lowry, this is a base because it accepts this proton.
Exactly.
Now, if we were to look at the Lewis structures, this is where we can see how this applies. And if this is a positive H, it doesn't have any electrons. So there's no electrons in this H.
Okay.
This is where Lewis comes in. Because this doesn't look like it'd be a Lewis acid base applied, it'd just be Bronsted-Lowry.
Yeah.
What you need to look for, though, is this has a spare pair of electrons that it's not bonding with. It can use these to bond with the hydrogen and then make your ammonium. That's where Lewis comes in, is he's looking for either you have a negative charge, which means you have spare electrons anyway, or you have a spare pair of electrons like nitrogen does in ammonia. Does that make sense?
Yeah.
Okay.
So that would make the hydrogen a acid.
Yes, because it accepts these electrons.
Oh, that makes more sense now. Okay.